All right. So once again, welcome to CS432 and CS536 data mining. Uh, Today we will basically start with the outline for the course, and we will then, following that, we will then also start with the introduction to data mining. So, so let me get started. I have the slides up here. Are the slides visible?
Yes, sir.
Yes.
All right. All right. So, so this is going to be a relatively large class, about 100 people. I do get your messages that you type in, but I would say that please don't have so many messages. So kind of overwhelms me. Uh, but in any case, messages is one way of communicating with me. All right. So let's get started, and some of your questions will be answered while we discuss these slides. So this is a course on data mining. There are actually two codes for this course. CS432 is meant for undergrads, and CS536 is meant for grad students. Uh, the difference between the two is kind of minor. We will discuss that shortly, and especially in the assessment, and we will discuss that shortly. But before I go into that, let me just quickly go over what the course is all about. So this course will provide an introduction to the concepts and techniques in data mining. And many of you may already know what data mining is, but we will formally define it again today. Uh, so we will discuss several content in this course. Start with the data mining process. We will discuss data pre-processing and various steps involved in data pre-processing. We will then talk about several key data mining tasks. One of them is frequent pattern mining or association mining. We will talk about cluster analysis as well. We'll talk about outlier analysis. We'll also talk about time series and a bit of spatio-temporal data mining as well. So these are very briefly the high-level topics for this course. So the focus of this course would be, of course, on fundamentals, gaining knowledge of the task involved in data mining, an idea of the implementation of those tasks, evaluation of those tasks, which is very important, as well as an exposure to tools, or you can say libraries that are available to solve some of these problems. So this slide is about goals. Let me go over it quickly. So provide a comprehensive introduction to data mining. So you want to develop the conceptual and theoretical foundations of data mining process. So we'll talk about the data mining as a process as well shortly today. So you'll get hands-on experience on the implementation of data mining algorithms and to solve specific data mining tasks. And in general, one of the goals of all of these courses is to give you more interest and be motivated about research in data mining. So data mining and other related areas like machine learning, natural language processing, and so on are active areas of research. Um, and of course, there are also active areas that are widely used in the industry. So this slide basically highlights some of the learning objectives. So you should be able to understand why you want to do data mining and what is the motivation behind data mining. So we will talk about several data mining tasks. You should be able to uh, understand in which situation you can apply which task and to solve which problem. So also there might be several algorithms for a particular task. So you should be able to decide which algorithm is best suited for a particular task and a particular problem. You should also be able to implement such algorithms and such solutions, and then also be able to evaluate them. So evaluation is also important, uh, just to make sure and to ensure uh, objectively how accurate or how reliable your results are. Uh, in this course, you will be exposed to various libraries that are commonly available out there, and you'll get hands-on experience on the use of those libraries. Regarding the functionalities, as I mentioned earlier, we will be focusing on some functionalities, not all, that are possible in data mining. We will be focusing on, for example, association mining, cluster analysis, outlier analysis, frequent pattern, time series analysis, and spatial temporal analysis. So we will not talk in detail about classification. So classification is often done in quite detail in other courses. We might introduce the concept of classification and maybe one algorithm, but we won't go into the details of multiple algorithms in classification. In addition to this, of course, there are many other tasks as well. So we won't have time to discuss all tasks that are possible in data mining. So the prereqs for the course are relatively mild. Uh, so in general, you should be comfortable with programming. You should be comfortable with data structures. So actually 202 is set as a prereq for the undergrads. So 202 is something that most computing majors take. So it should not be a problem. The idea of putting this as a prereq is that you should be able to understand high-level algorithms and then also be able to implement those algorithms in code. And those algorithms may include some basic data structures like hashes and indexes and trees maybe. So you should be able to implement those in your code if required. So databases is not a prereq, but if you have taken databases, you will see some overlap of terminology used in this course. If you have not taken databases, then I think those terminologies are not that difficult and you should be able to understand them during this course. So databases is not required, but if you have taken it, then well and good. It might add somewhat to your understanding, but not essential. So you need some basic math background as well, which most of you must have taken over your academic career. Uh, so this includes linear algebra, calculus, little bit of statistics and probability, not much. Actually, in this course, there is very minimal discussion of probability. In the machine learning course, for example, or in the NLP course, you need a bit more of probability. But in this course, you would not see much of probability. So in that sense, it's relatively light on the math part. So you should, of course, be comfortable with programming. Uh, Python would be used. Java is also possible. So, so, so these are some of the prereqs and the requirements before taking this course. So any questions? All right. So if you have a question, you can even speak up, unmute your mic and speak up. You can also send me a text message. But if there are multiple text messages that are sent out very frequently or uh, close distance apart, then it does distract me because I need to listen to what is being said in the text message. But if it is once in a while, that's not a problem. So you can also ask question through a text message. As I said, if there are not too many text messages being floated around, then that's possible. All right, so let me move on to the grading. So grading is something that all of you might be interested in. And this was actually modified slightly yesterday. So we will have 8 quizzes, around 8 quizzes, of course, and one might be dropped. If we have 9, we might drop 2. And these quizzes would be held online at the end of each lecture. Not each lecture, of course, at the end of the lecture in which the quiz is announced. And the quizzes would be on Zoom and LMS. So they will be online. And as I mentioned earlier as well, you will be required to have your video on during the quiz. Quiz will be about 10 to 12 minutes long. So you'll have about 4 assignments, which will comprise about 15%. Assignments are individual. There will be a project, 20% project. And there might be a slight difference between the projects for the undergrads and the grads. So this is where the difference might occur. Of course, the percentage weightage would be the same, but the grads might have to do a bit more. The projects would be pre-designed for you, and they will be assigned to you. And of course, they will be in groups. The group size would be decided later on, maybe up to three people. And for the grads, there might be an additional sub-project, which would be decided or mentioned, discussed later on. The mid and the final exams I have decided to be held on campus. This was a decision that was made in the school yesterday. So we are allowed to have exams on campus, even if the lectures are online. So mid would be 25%, final would be 25%, and they would be most likely be on campus. Of course, if there is other unforeseen circumstances, they might be moved online as well because of the pandemic. Usually my exams are not cumulative. So the midterm would only comprise of the mid material. The final would comprise of material mostly post-mid. So that's why they also have similar weightages. Okay, any question here before I move to the next slide?
Sir, will there be any unannounced quiz?
Most likely not. The quiz would be announced in the previous lecture. So you can say you will have about 2 days notice. Typically, I don't email announcements of quizzes. I will mention it in the previous lecture.
Sir, I had a question regarding the project.
Mm-hmm.
Sir, the group that will be formed for the project, can it be a mixture between grads and undergrads, or will that be discrete?
That is a good question, actually. Grads and undergrads. I think since we are, I have not finalized the grad extra part. But I think it will be kind of difficult. Probably you can. So I would say we will discuss this in more detail later on. I'm not 100% sure because it depends on what extra project I decide to give to the grads. So if you have a mixture of groups, then at least that group can do the project that is for the undergrads. but the additional project for the grad might have a different group. So, maybe that might work out, but I think that would be decided later on. अच्छा, इसमें एक और क्वेश्चन किसी का टेक्स्ट पे था. What was that question? अच्छा, okay, the exams would not be coding. It would be concepts and simple, you can say, pen and paper, numerical concepts, which can be theoretical as well, and some numbers as well. But you won't be asked to write code. Of course, data mining coding can be given as extensions to snippets, but that is tested in your assignments only, not in the exam. You may have like pseudocode or algorithms in the exam that you might have to kind of interpret, but not like in the algorithms paper where you have to find big O's and other stuff or complexities and stuff like that. We won't be testing that in your exams. Of course, you would see that in the theory, in the discussion in class, and of course in the books. So let's quickly revise or remind ourselves regarding the policies. Some of these policies would be familiar to you. So I've already discussed about quizzes. Quizzes would be announced mostly. They will be online at the end of each lecture. They will be on Zoom and LMS. You would be required to have your video on during that time. If we do record that session would be private. It would not be made public. Similarly, for the exams, of course, if the exams are online, again, they would be on LMS and Zoom. But right now, we are pushing for on-campus exams. So on-campus exams would be like regular exams in a classroom with paper and pen and pencil. So for the assignment, the submission policy that I follow in my courses is described here. You have 10% deduction for 1 day late, 20% deduction for 2 days late, and 100% reduction if you are late by more than 2 days. And of course, if you want to ask for an extension, you should plan yourself accordingly and ask for extension based on justifications sufficient time in advance. Grace days for the assignment. I don't know what that means. We already have 2 days grace day, but with the penalty. All right. So this slide is about sharing and plagiarism, copying. So you are all familiar with non-ethical behaviors. Regarding your assignments, you can discuss assignments among yourselves, but whenever you sit down to write and do your assignment, you should do it independently, because each assignment has to be submitted independently and it would be evaluated independently as well. So whatever you do and submit, you should be able to explain to others. So you cannot just simply copy from a friend and post it as yours. So of course, if you're caught violating some of these policies, you can be reported to the DC. Okay. So similar rules apply for plagiarism. Plagiarism basically means that you are copying stuff from others, especially the web and other published material without proper citation. And the idea is that even if you do copy something, you should at least refer to it and make it clear that this is not mine and this belongs to that and that person, so and so. So just a couple of words on inclusion and harassment. So we are trying to promote inclusion, which means that people with different abilities, with different uh, characteristics can work with ease without difficulty in our environment. So in general, try to respect diversity. So diversity is prevalent in the world today, and it's prevalent all times. So diversity does broaden our perspective. So respect diversity. And secondly, be professional in all your interactions. So professional also includes ethics. So you know what is right, you know what is wrong. So do what is right and avoid what is wrong. So if everyone follows these rules, I think we will certainly be living in a great environment, in a great society. So as students of higher learning and people who have attained a certain level of education, I expect that you understand these terms, these conditions and these requirements, and you follow them. Attendance is not recorded in this course, but do try to attend the live lectures because you get an opportunity to discuss content with me as well as with fellow students, and which kind of enriches your learning experience. So basically my learning philosophy is that, and actually this is the general learning philosophy if you want to benefit from learning, is that you have to be active. You cannot be passive and then say that I have not learned much from a particular course or from a particular experience. So you have to be active. Active in lectures means that you come prepared to the lecture, ask questions, discuss with others. Beyond the lectures mean that you study stuff from other places as well. You do get involved in activities, which is like assignments and projects and others activities relevant to the learning of a particular subject. So all of these activities will promote your learning, a learning that would then last for you rather than just for this particular course. So regarding grading, I'm not a very strict grader in general, but I still have to follow some ethical guidelines, which means that I need to rank you based on your performance that I have obtained from the instruments. So that ranking would then lead to a grade for you. So any questions on these 3 slides? Sure. So someone raised his or her hand.
Sir, I wanted to know more about the project. What will it be about, and will it be individual project or a group project?
The standard project that all of you would be doing if you are undergrad or a grad is we will be giving you a problem statement as well as a data set, a real world data set. And you would need to go through the various steps required to perform data mining on that data set and to achieve the goals of that particular problem. So in other words, the project would be uh, somewhat guided for you. You can assume that you are in an industry and you are given a problem in a data set and you have to then solve that problem using data mining techniques. So that's what you would be doing in the project. We will be fixing 2, 3, 4 projects and assigning them randomly more or less to you. and you will have to follow or do that project. The project, of course, would be in groups. The group size, I think around 3, I would say, maybe more because this is going to be a large class, but at least 3.
Okay, so thank you.
All right. So there are a number of textbooks on data mining and related topics. We will be relying primarily on 2 books. One is Introduction to Data Mining by Tan and others. This is the 2nd edition that was published, I think, in 2019. The other book is Data Mining Concepts and Techniques. This is by Jiawei Han. He is at UIUC. And this is the 3rd edition published way back in 2012 and 13. So this is an older book. Both of these books we'll be using interchangeably, and both of them have very similar content. Although personally, I like the first book better. It is written in a better way. So the 3rd book is Data Mining, the textbook by Agarwal. This is also a good book. It also has more advanced topics. The first 2 books have very basic topics, basic meaning that doesn't cover all the tasks in data mining. But this book by Agarwal has many more tasks. And for example, time series and stuff like that, we will be covering from this book. Just a second. All right, so this is the course content, big picture. Broadly, we'll be starting with the introduction today, introduction and motivation and data mining process. We'll then discuss data preprocessing and the various steps that are involved in data preprocessing. This includes data exploration and visualization. And then we'll talk about association mining or frequent pattern mining. Within this, we'll also talk about sequential pattern mining and maybe a bit about graph mining, because most of these algorithms are similar. The basic algorithms, of course, are similar. Of course, there are advanced algorithms as well. After that, we'll spend some time on cluster analysis. There are a number of techniques in cluster analysis. We'll discuss those. We'll then talk about outlier or anomaly analysis or detection, which is quite related to cluster analysis, but there are also some other techniques. And then finally, we talk about time series and a bit of spatio-temporal analysis. So this is the slide again. वो पीछे move होगी थी. So there are, as I said, many other resources available. You can also Google stuff on the web, and you will get lots of material on the web, which you can use to supplement your reading. So the course website is on LMS. The tab is already set up. I have just put in the outline there. Of course, the outline की जो क्या कहना चाहिए grading वहाँ थोड़ी सी different है, यहाँ different है. I'll change it there. But I'll also be placing the slides there as well, and most likely I'll put them before the lectures. आज नहीं मैंने डाली, but later on, hopefully you should be able to find the slides before the lectures. So I will also be recording the lectures and putting them on YouTube. YouTube channel is, I'll also email you later on, but the channel is CADE Lab Lums. So on this channel, you would be able to find last year's videos as well. You can look into those as well, but we are going to put up new ones as we go along this year as well. Content-wise, from last year, we don't have much of a change, same content. So you can use the previous videos as well, in addition to the current videos. So I have not finalized my office hours. I will let you know through an email. So I have two back-to-back lectures on Tuesdays and Thursdays. So if things goes out well, then I might be giving these lectures from home. So if I do this from home, then on Tuesdays and Thursdays, I will not be on campus. So I'll probably be on campus on Monday, Wednesday, and Friday. So I will have office hours on Zoom as well as physical office hours on campus. So we have a number of TAs. I've listed some names here, but the TAs would be contacting you also and informing you about their contact information and office hours. So we have Aisha, Majid, Mufaza, Saad, Mursal, and maybe one more TA. So about 5 TAs. So we have about an enrollment of about 100. So that's, I think, a bit about the modalities of this course. Any questions before I move on to the introduction? So I'm assuming that all of you are on campus or can be on campus for the exams. So we will try to schedule the mid on probably a weekend. And of course, the final would be on the slot that is assigned or decided by RO. And the mid would be in the 7th week, most likely. And we will decide that as we come closer, or maybe by next week, so that everyone knows exactly when the mid would be held. All right, so no further questions. So, okay, so let's then so I'll use these slides to quickly introduce data mining, motivate data mining, and talk about the data mining process. So these slides are from Data Mining Concepts and Techniques by Cam Han. So let's go straight to. So let's start with what is data mining? So very briefly, data mining is discovery of knowledge from data. So to further expand this, so we are talking about extraction of interesting. Not so we have used the keyword interesting, and we will qualify this keyword with some other keywords. So let's say it's the extraction of interesting information from large amounts of data. This is the simple definition of data mining. So when we say interesting, we typically mean something that is non-trivial. Secondly, we mean Basically, what does it mean by non-trivial? So something that we did not know before. So, and secondly, so for example, to give you an example, so if someone tells me that the average weight of females at LUMS is lower than the average weight of males students at LUMS. So that is something that is known, that is not something very interesting or exciting, it's already known. So that's trivial. So I want something that is non-trivial, that is previously unknown. So, so all of these terms explain what is interesting. So implicit again refers to that something that is not very obvious. So it wasn't obvious, but we found out through the data mining process. So previously unknown. So it might be that there is something that is really interesting, but it has already been discovered. So you can talk about maybe things like even in the case of astronomy, so there are uh, you can say entities in space that were discovered very recently. But once they are discovered, so it is already known. If someone comes back today and tells me that, oh, I saw that particular entity in space, so that is not very interesting again. So it's already known. So similarly, you can think of in customers' data sets or in any other environment where you are applying data mining. And finally, whatever interesting means that it's potentially useful. And this is where we sometimes also use the word actionable. So we want information or knowledge that is actionable, something that we can use. For example, if it is a company, we would like to use the knowledge that we have extracted to maybe further enhance our product services, product lineup, or to improve the quality of a particular product, or to maximize our profits and so on. So something that we can use productively, actively in whatever environment or setting that we want to apply it to. So is that somewhat clear? So very simple extraction of knowledge or information, you can say, but that information has to be interesting from large amounts of data. And interesting means that it's non-trivial, it is actionable, it is previously unknown, it is implicit, and so on. So data mining is often interchangeably used with KDD. KDD means that knowledge discovery from data. And as you see, as we saw in the definition, data mining also is knowledge discovery from data. So KDD and data mining are often used interchangeably. Previously, many other names were used for data mining, but some of them are listed on this slide, but they are not very common nowadays, and most people have forgotten them. But just one other comment. Uh, so data mining might be considered a misnomer if you compare it with things like gold mining or the mining that we do in traditional uh, settings where we try to find something in earth. So we dig into the earth and maybe find some pearls, or sorry, pearls do not occur in earth, but some precious metal, for example, like gold. Uh, so, but what happens? We are gold mining, but what are we mining? We are mining earth. So in that sense, the name should have been knowledge mining. But of course, we don't use that name. We say data mining. So we are going through data to find knowledge, and we call it data mining. And as I said, KDD is also used interchangeably with data mining. So there are some other terminologies. I'll just mention them again in the later slide. I'll come back to that. So now the question is everything data mining, or simple data processing is also data mining? So this sometimes can be a bit confusing, but the simple answer is, so if you are you already know what information you are going to extract from data a priori before you apply it on the data, then generally that is not data mining. In data mining, we know the type or the general characteristic of information that we are able to extract, but the actual information we don't know that information. So for example, if you write an SQL query, so you have explicitly specified exactly what you want. And even before you saw the data, you can deduce what you will get from the data. So that generally is not called data mining. So that is deduction, while data mining in that sense would be more of an induction. Okay, so I'll come to that regarding some other terminologies. So let me just cover a few more slides. Okay, so data science is a term that is also commonly used. And of course, there are courses named according to data science as well. So this slide gives you evolution of science. So, and of course, this is somewhat approximate. So, and of course, grouped together. So generally before 1600, we have empirical science. So people went out and did experiments and deduced the theory behind several physical phenomena, different physical phenomena through experiments. So you can think of, for example, the laws of light and so on. So for example, the laws of motion, for example, also, although that was not totally uh, before 1600, but usually, for example, you talk about Archimedes' principle, for example, for rotation, that's also purely empirical. So that was empirical science based on experiments. So if you then look at the next phase, 1600 to 1950, we had a great focus on theoretical science. So, and here you have the laws of motion actually fall here in a better way because you have theory for the laws of motion, gravitational laws, and for example, Einstein's theory is also part of this phase. So a lot of emphasis on developing theories behind what we observe in nature. So, and of course, you had theoretical physics, you have theoretical biology, theoretical chemistry, and so on. So from 1950 to, I would say, around 1990 and even later, we have computational science. So almost all science disciplines developed a third, you can say, subfield, which we call computational science. For example, computational biology, computational physics, computational chemistry, and so on. So here the emphasis was on not conducting experiments, but running experiments through simulations on computers or modeling physical phenomena through on computers. So simulations and modeling was computational science. But in more recent times, since the mid 1990s, we now have a new science, which we can call data science. So what is this science? This science deals with data. So now we have data. We are trying to now discover or find about concepts and theories and phenomena from data that have been generated by those, let's say, uh, from nature, for example, or from experiments. So this is data science. And now also, of course, because of this, each field has developed a data science component. For example, bioinformatics, for example, is essentially data science. So this name was actually proposed way back in 2002. Jim Gray, by the way, has passed away. He belonged to Microsoft. So But data science as a name became very popular in the last 5 to 10 years, I would say. It became more commonly known in the last 5 to 10 years. So what is data science? Basically working with data and trying to use data to deduce laws, theories, models, and so on. Okay. So now the question is, we have talked about two terms, data mining and data science. What about machine learning? What about AI? What about, for example, uh, in the last decade or so, business intelligence, for example, or data analytics? So all of these terms are actually related. So what are the terms that are used? For example, data mining and KDD. These are, of course, the same thing. So we have, of course, data science. So I talked about, for example, what is machine learning. All right. So machine learning, you can also add AI here. So data analytics, this is a term that is sometimes also used in the industry. In the older industry, you also had something called business intelligence. This is now gone out of fashion. And then also in the last 5, 10 years, another name that came up was big data. So all of these names actually are related. So for example, if you talk about machine learning, so machine learning are about techniques. It's about how to learn from data or experience. So of course, in data mining, as we will see, many of the techniques are based on machine learning algorithms or are extensions or derivations or modeled along machine learning algorithms. So if you talk about, for example, big data is often defined as the 3 V's. You might be familiar with that. The 3 V's. What are those V's? So we have volume of data, and we have variety of data. And then, of course, we have, what is the third V? Volume, variety, velocity. So this is essentially trying to characterize that we have lots of data available nowadays. So there's huge amounts of data. That data is coming in streams in large amounts continuously. So that's velocity. And there's a variety of data. So data from variety in the broadest sense, from different sources, different types, and so, for example, different types could be, you have video data, you have audio data, and sources could be from different organizations, different entities. So big data is basically this thing. But again, what do we want this? How do we use this big data? To use this big data, you would need the techniques in machine learning, you need the techniques in data mining, and so on. So business intelligence and data analytics. So these terms are kind of less fashionable nowadays. They were fashionable in the older times. So business intelligence was basically intelligence derived from data and applied to business settings, business processes and procedures. So again, at the back end, you still had things that were found in data mining, in machine learning, in AI, but it was called business intelligence. Similarly, data analytics, this is essentially data mining. Basically, you're developing uh, so basically data analytics, as I said, would be a replacement, direct replacement for data mining. So is this somewhat broad comparison easy, clear? So there is, the bottom line is there is a lot of overlap in these terminologies. So, but you need to kind of put them, kind of some things are highlighted more in some terminologies, others are not. So you can say, put it in this way. All right, any question? So we did not talk about data mining's motivations. Why do we need data mining? And this is quite obvious to everyone, so that's why I'm discussing it later. So actually the two main points. So we are now generating lots of data. So, and why are we generating lots of data? Because automation. So everything is automated. You have sensors that are monitoring, that are recording information, and uh, you have actual physical systems that generate data. And the second thing is, of course, storage. We are able to store that data. So we have generation, we have storage. So both of these aspects have led to the availability of large amounts of data. So if you have large amounts of data and you're not using it, so that's useless or just kind of taking up space somewhere. So that's why data mining came into popularity. So we were drowning in data, but we are starving in knowledge. The idea was that data has nuggets of knowledge within them. So we would like to explore that data and extract the relevant nuggets of knowledge, uh, something that we can act upon for our various endeavors. So this is the key motivation behind data mining. So you have data everywhere. If you talk about lumps, for example, everything is, there's lots of data being generated. So you have cameras at multiple places. For example, now I'm recording your uh, lectures. That's also data in a way. If you talk about the Zambil system, so you have lots of data there. Data is being generated. Whenever you register into a course, new elements of data gets recorded somewhere. So in every setting, you have lots of data. So now you need tools to explore the data efficiently, and that essentially is data mining. Okay, any questions?
One question here. Um, is data retrieval anywhere related to data mining, or is data retrieval part of data mining?
किसी का क्वेश्चन कोई तो आवाज नहीं आई सही.
Am I audible?
जी जी आप बोले.
मेरा क्वेश्चन ये है कि डेटा रिट्रीवल जो है वो डेटा माइनिंग का पार्ट है और वो या वो सेपरेट फील्ड है.
Data retrieval, if you talk about the process, yes, it is part of data mining. जैसे इस प्रोसेस में इस स्लाइड पे आपको प्रोसेस की फिगर नजर आ रही है. So it is part of data mining in that sense. But जो हमने पीछे मैंने एक distinction की थी कि data mining, how is data mining different from databases? So in that sense, then it would not be similar. So data retrieval essentially is what we do in databases. So essentially you write a query which explicitly specifies what you want to retrieve from data. Okay? And before even looking at the data, you know pretty much exactly what you will get. Of course, each values तो नहीं पता चलेंगे, but structure आपको पता चलेगा क्या आपको मिल जाएगा data से. ठीक है ना? So that essentially is retrieval. But as you see in this slide, data mining is often considered to be the entire process, or it's part of the entire process. इस figure में आप देखेंगे इसको mentioned as a part of a process. बीच में डाला हुआ data mining. So let's go over this and you'll get a better idea. So if you look at the bottom left, you have data sources. So we talked about variety. So there could be a lot of variety of data sources from different locations of different types and so on. So from that, you basically have data selection and maybe some pre-processing done on them. And usually if you do pre-processing and create a consolidated database, that might be called a data warehouse. Data warehouse or a data lake or a data collection, whatever you want to call it. So that's a consolidated data repository. Of course, when you have multiple sources, data might be quite diverse. You will need to do pre-processing. There might be duplicates information. We need to remove them. There might be erroneous information. You might need to fix that. So all of that is part of pre-processing. Once you have done that, you can say consolidated data of reasonably high quality. So pre-processing essentially is done to improve quality. We will talk about pre-processing, I think, starting from next lecture. So once you have a consolidated data repository, and now, of course, this data repository would contain the information that you want to mine. So from here, you can do data selection again, and then apply various data mining techniques. So here you see that data mining is a separate box in this process. Okay? And the whole process is called KDD. But previously, as you mentioned, I said data mining and KDD are same. So ये दोनों interchangeably use होते हैं industry में. So you should not be too much surprised with that. Okay? So data mining is our techniques that extract relevant information. जो information आती है, that has to be then evaluated. Once information is extracted, it has to be evaluated, meaning that you need to make sure whether it's interesting or not. Remember, we want interesting information. So once it has been made known that it's interesting, then that means it's actionable knowledge. Interesting knowledge is then used by the consumer, whoever the consumer is. You notice in this figure, there are some loops as well. So there may be loops from the output to the data mining algorithm. So meaning that once you have some output and you are not satisfied with the output, evaluation gives you poor results, for example, you may go back and change the data mining algorithm or maybe tweak the data mining algorithm. Algorithm may have parameters. So you have to tweak that. Similarly, you might sometimes even want to go back to your original data and maybe change your data itself. Maybe you found out that data was not correctly processed, or you wanted the data in a different format. So you had to go back and go to the data and change it again and go through the process again. Okay? So in other words, and similarly, I talked about pattern evaluation, which is usually done at one stage through some automatic objective measure, which we oftentimes call interestingness measures. But eventually, it is a human who finally decides whether a particular piece of information is usable or not, or actionable or not. Okay? So eventually, it's a human being who decides whether he wants to use a particular piece of information, or not. Okay? So दो इसमें concepts आ रहे हैं. So there are two concepts here. One concept is that data mining and this whole process, KDD process, is iterative, meaning that it's not like you push a button you get the results and you're done. If you're lucky, yes, maybe, but most likely in practice, you will have to do iteration, come back, do some changes, do some tweaks until you are satisfied with your results. So iterative. The second important keyword that you need to take away from this is that it is interactive. Yes, we do have automatic techniques for extracting information, and we also have measures that can be implemented to automatically verify or evaluate the patterns. But at the end of the day, there is some business analyst, some decision maker who needs to make the final decision. So in other words, there is always human interaction involved in the data mining process. So human interaction and iterative. Is this point clear? So this figure, as I said, is the KDD process, knowledge discovery from data or database process. And in this process, data mining is mentioned as one step. But in some other figures, you might call the whole process as data mining. Okay? So both are possible. But the takeaway, as I said, are two. Data mining or KDD is interactive and it's iterative. So in practice, it is not fully automatic. You can call it as semi-automatic. So I've already talked about business intelligence. So this figure actually shows the business intelligence pyramid, which is also applicable to data mining as well. So basically, the information pyramid at the lower level, you have at the lower level you have large volumes but raw data. At the top level you have small volume but knowledge, something that is usable. So the data mining process or the business intelligence process basically goes from large volumes but potentially useless information to small volumes but potentially highly actionable information. And of course, along this path, different users play different roles. So they may be a DBA who is primarily concerned with raw data. They might be a business analyst. They might be a data analyst. They might be a data scientist, data engineers. So these terms are also used in the industry as well. So data engineer, for example, is more about working with data in different settings. Data scientist is someone who is working with data mining algorithms itself. And of course, there are other terms that are commonly used as well in the industry. So we are kind of running out of time. So I'm just trying to think what next to present before I wrap up. So I think before we go into further details, so there are actually numerous applications of data mining. Just very quickly, let's say you have customer data at an e-commerce site. So it could even be, for example, let's say Carrefour, for example, not even e-commerce, a retail store. So you have customer information like customers' demographics, for example, age and income, and for example, from where they're located. But you also have their buying behavior information. what someone has bought at different time, at different stores over time. So just to give you a quick highlight, and we'll discuss this in slightly bit more detail next time. So for example, if you want to kind of group your customers based on their buying behaviors, which sometimes is also called in the business industry called customer segmentation. Although segmentation is has slightly different connotation, which we'll discuss when we discuss clustering. But customer segmentation basically trying to understand your customer. So meaning that you might want to find a group of customers who are interested in, for example, clothing items, a group of customers who are interested in, for example, groceries only, a group of customers who typically buy, for example, electronics. So discovering such segments is part of, as an example of data mining. And why this is interesting? Because then you have groups of people to which you can do target marketing. So let's say if there's a group that you have found out that buys clothing items, then you can market that group with clothing ads. And if you market that group, for example, with electronics, that group is never going to buy electronics based on the previous history. So that's wasting your money. So that's a way of using data mining. Just one quick example. Again, taking this analogy of a customer data set in e-commerce. For example, let's say based on the customers, a particular customer A's behavior in the past, you want to determine whether A would purchase, for example, I'm giving a very specific example, let's say a washing machine. So you have this customer A in your database, and you have all his previous buying habits. Now you have a specific hypothesis or question, you can say. So what is the probability or likelihood that this customer will buy a washing machine in the next 3 months or the whatever time period you want to specify? So again, this is a data mining problem, and the data mining algorithm might probably output that the person might buy this thing with some probability, let's say 0.7% probability. Washing machine. So this is again an example of data mining. So again, another example regarding this data set, for example, maybe you want to find customers that are kind of anomalous, exhibit anomalous behaviors. Why would you be interested in that? It might be because of fraud. For example, you know a particular customer's A's behavior, and suddenly that customer A, who typically buys groceries, started buying electronics. So that could be flagged as an anomaly. It might be because of fraud, because maybe someone has stolen his credit card or his identity. Okay? Or you might also want to find out such anomalies. For example, anomalies could be like, there might be people who come infrequently, but then buy huge amounts of stuff. So maybe they buy a very expensive watch. You would like to know such people. Who are those people? Because then maybe you can give them specific, you can target them for specific purposes. So maybe they buy, for example, a Rolex watch, which is extremely expensive, or for example, they buy an Apple iWatch. Okay. So all of these are examples in this particular setting of data mining. And in the next lecture, we will give names to these specific tasks. And with that, basically, we'll conclude this chapter and move on to the next chapter of data understanding and preprocessing. So in the next lecture, we'll start with this, some leftover stuff from chapter 1, and then we'll move on to the remaining chapters. So, okay. So any questions? Any questions? So, okay, any questions regarding enrollment or any other issue for this course? ठीक है. So I think if there are no questions, we can end the session today.